Hello and welcome everyone to Scientists in Action Discovering Teen Rex. I'm your host Kate from the Denver Museum of Nature and Science, where we are in fact filming live today. However, we are in a space that not many people get to see. We're behind the scenes, we're in a lab that I'm going to let our scientists talk about in just a minute here. But before I introduce them, a couple of housekeeping items I want to take care of. First and foremost, if you're going to be our on-camera school, I'm going to ask that you keep your mics muted and your camera turned off until we're ready for you in about 15 or so minutes. If you are not on camera and you have questions, I love it. We have an open chat, so you can be adding those questions to the chat throughout the program, and we'll make sure our scientists get them. On that note, I want to introduce you to Salvador Bastian, as well as Natalie Toth. Would you like to tell us maybe what you do here at the museum, as well as where we are and what are some of these cool things we have on the table behind us? So take it away.
Hi, I'm Salvador. I'm a fossil preparator here, which means that during the warm months of the year, we go out into the field to collect fossils and bring them back to the museum. And then the rest of the year, we're in spaces like this, cleaning those fossils up, getting all the dirt and rocks off of them, getting them ready for researchers and for exhibition.
So hi, my name's Natalie. I'm also a fossil preparator here, and I have the privilege of working alongside Salvador, along with a group of interns, other staff members, and volunteers. And just as Salvador mentioned, we work to go out and find fossils, collect fossils from the field across the entire Rocky Mountain West. We bring them back here behind the scenes at the Denver Museum, and we work with specialized tools to clean them and stabilize them and get them ready to share with folks like you all. So today, I thought it would be really fun to share with you guys a little bit about T-Rex. But before we jump into that, Kate has some really interesting questions to ask you all on one of our polls.
Yes, we have poll questions. So we would like you to think about, how big is an adult T-Rex? Is it the same length as 40 boa constrictors, which sounds like a horror film, terrifying, so many snakes? Is it the same length as a school bus, perhaps like a school bus that you took to get to school today? Is it the same length as a football field, or is it the length of 20 people? How big do you think the dinosaur is? Amazing. I hope you had a dance party as we did here. We've got a couple different responses. We have a slight majority for the same length as a school bus. The same length as a football field is also an option, and same length as 20 people. No love for the snakes. No one said 40 boa constrictors, but what is the answer?
So most of you were correct. So the T-Rex that we have here, I would say is closest in size to a school bus. And an adult T-Rex was around 40 feet long. So great guesses. Great job, you guys. And we'll talk a little bit more about T-Rex and its size in just a little bit.
Awesome. Yes. Good to think about. School buses. Good thing we don't take T-Rexes to get to school, because some of you might not make it. Let's go ahead and pull up another poll question. Despite the name, T-Rex is not a lizard. Instead, their closest living relatives are crocodiles, birds, Komodo dragons, lemurs, or sharks. Amazing. All right, let's see how our friends did. Ooh, okay. We've got like a diversity of thought other than lemurs. Sorry, lemurs. Apparently you are not related to T-Rex, and that is right. We do have a response for crocodiles, sharks, a couple for Komodo dragons, but a majority say birds. What is the correct answer? What is their closest living relative?
These are all fantastic guesses because crocodiles and Komodo dragons are animals that help us learn about how T-Rex lived, but birds is the correct answer. Most of you got it right. That's the closest living relative to T-Rex. Birds evolved out of the same group of dinosaurs, theropods, that T-Rex was a part of.
Wild to think about. All right, we've got one last poll question, and unfortunately, we do not have the fresh beats to play over this one like we do with the other ones. Maybe our scientists will sing to you. This particular T-Rex is special because it is not often we find teenage dinosaurs. It was found by kids. It was remarkably complete for a dinosaur find, or maybe all the above. All right, let's go ahead and close that poll and see how our friends voted. Ooh, okay, we've got a couple different responses. We have a couple folks who said it is not often we find teenage dinosaurs. We have one guess for found by kids, but the slight majority said all the above. So why is Teen Rex so special? Tell us about it.
Yeah, so great job. All the answers that were listed on that page are absolutely correct. So this is a really special dinosaur because it is pretty complete for a dinosaur fossil. It was found by kids and it's a teenage dinosaur. So really remarkable fossil in general. So Teen Rex was a really fun find. We got a call back in 2022 that some of our colleagues and friends up in North Dakota had found some chips and chunks of broken up dinosaur bone. And they texted a picture of this dinosaur bone to our curator of paleontology, Dr. Tyler Leeson. And I think, yeah, great. So we have a picture here of one of the young kids that had found these chips and chunks of dinosaur fossil. So this is Liam, and he's laying next to the shin bone from the dinosaur that they had found. We get this picture and decide that last summer in 2023, we would bring our team of staff and interns and volunteers out to the field with us to do a little investigating of what this could possibly be. And so as we're digging and digging, we start to uncover more and more of this dinosaur specimen. And we're kind of still second guessing, kind of still curious about what this is. And it wasn't until we started to find things in the quarry that looked a little bit like they could be some sharp teeth. And I think we have a picture of this as well that we can share. Wonderful. So if you guys see this picture of the brush, where the bristles of the brush are, the soft part of the brush is the front part of a dinosaur's lower jaw. And there are a few little black splotches on there that look like little black rocks. And those little black rocks, if you zoom in a little closer, they're actually the tip of teeth. And those are teeth from a meat-eating dinosaur. So you can imagine how excited that we were, the kids were, everyone that was out with us was when we realized that this dinosaur is not any old dinosaur, but it's a really remarkable fossil. It is, in fact, a T-Rex. So we spent the last several weeks last summer, digging this fossil out of the ground and finding a way to safely bring it back here to the Denver Museum.
And so we wrapped this fossil up in plaster. I think we've got a picture of that. We found a bunch of these bones and wrapped them all together in this big blob of plaster. And we flipped them into a helicopter net and then flew them off the top of this hill with a Black Hawk helicopter and drove this big block of rock and fossils back to the museum, where our amazing colleague, preparator Alex, has been working on cleaning these fossils up. And I think we've got an awesome photo of the fossils she's been working on. So she's discovered all sorts of amazing things in here that we knew we had a jaw, but we had no idea that we had this complete, beautiful lower jaw as well as the upper jaw and most of the skull. And we definitely didn't know that that big palm leaf was preserved in there. And this is amazing because it's two parts of the ecosystem, and it shows that T-Rex was living in this tropical environment in North Dakota. I think we have a photo of what that environment might have looked like. And it really gives us an idea of the plants and animals in this ecosystem and what we call the Hell Creek Rock Formation, what that actually is. And so as Alex has been preparing these fossils, she's pulled a lot of cool things out. We have lots of really beautiful teeth you saw in that photo that are preserved in the jaws of the dinosaur, but we also have lots of loose teeth that probably fell out of the upper right jaw, which is still buried in that fossil jacket. So we've got all these different sized teeth. Here's a little bit bigger one here. And as you go towards the back of the jaw, you get these little tiny baby teeth for scraping things down that dinosaur's gullet. And then one of my favorites is one of these bigger teeth from about midway down the jaw, a big chomper like a steak knife. And these teeth have little edges with serrations, just like a steak knife or a saw on the side. And something that's super cool about this one, and something that I'd love everyone to put on their scientist hat and think about, is that you could see on the tip end of this tooth, it's really light colored, a lighter brown. And as you move to the top of the tooth, it's a much darker, richer brown. And I think we have a photo of this tooth when it was still in sand that maybe shows those colors a little bit better. And I would love to see in the chat if anyone has any ideas for why the tip of the tooth is a lighter color.
Yeah, so teachers, students, however you have those computers set up, you can go ahead and put your guess in the chat. For Salvador's question, why do you think this tooth is two different colors? Kind of interesting. All right, someone says from the food it ate. Potentially. Maybe it is used more than the back teeth, or it is old. Something it ate, something about being stained. They ate at the top. Oh, so like maybe just part of the tooth was used for eating, I think. Interesting. Okay, so
Well,
what is the answer?
These are all really great guesses, and they get us towards the answer. But this line in between the light part of the tooth and the dark part of their tooth is actually where the gums of the T-Rex came to. So this whole part was beneath the gun going up into the T-Rex skull. And this was the exposed part that you guys were talking about that it was using to eat with. So we've talked about some of the awesome fossils and how complete this dinosaur is. We've talked about the story of discovery. But the last piece of why this is so interesting is because it's a teenage dinosaur.
Yeah, so, we find over the last, century or over a century, there have been dozens of T-Rex skeletons that have been collected by paleontologists from around the world. And a lot of these skeletons are of adult T-Rex dinosaurs. And so our fossil, Teen Rex, is so special because there's only been maybe 4, 5, or 6 of these dinosaurs of this age that have ever been uncovered. And so we get, we're really excited in the field when we are finding these different pieces and parts of the dinosaur skeleton. One of the first bones that was in that very first picture we showed you all was the shin bone or the tibia. So if we take a peek at the diagram here and we look at the dinosaur's leg, there's pieces of, this is what Liam was laying next to when we uncovered the fossil or started to uncover the fossil. And we knew in the field that, we brought a tape measure out and measured the length of it. It was about 80 centimeters. And that is much smaller than an adult T-Rex. So that was our very first clue that we may have had a teenage dinosaur or something that wasn't fully done growing into an adult size yet. Another clue, and something that we're continuing to work on here at DMNS, is we're going to be sampling that shin bone to understand exactly how old this dinosaur was when it died. So if you come over and take a peek at this fossil, you may notice that there's a perfect hole right here that is drilled in the side of this shin bone. So this is an example of how we take samples of dinosaur bone to better understand how old the dinosaur was when it died. What we can do is then take the piece of bone out. And so this is an example. It's not from T-Rex, but it's from one of its relatives. but we get what kind of looks like a tree cookie. And if you've ever looked at the tree rings that are inside of a broken or cut tree, you can actually count the layers of tree rings, and you can do the exact same thing for dinosaur fossils. So if we look closely at this, you can see that there are a few different lines of different colors that are preserved here on the inside of the bone. And by counting these different rings, we can get a better understanding of how old the dinosaur was when it died. So I guess stay tuned. We have some science to work on here at the Denver Museum, but hopefully our guess of this dinosaur being about 13 to 15 years old we'll be able to have a better understanding of that as we complete our histology analysis. One of the other, I think, really cool parts about this fossil that Salvador had mentioned is that we didn't only find a dinosaur inside of this field jacket. We also found remains of plants preserved alongside this animal. So Salvador has a really beautiful fossil here. Oh, excellent. So this is an example of one of the leaves that was preserved alongside the T-Rex skeleton, and an example of one of the several leaf fossils that we found when we were out in the field. So this is a little leaf fossil, but if we go to that picture that was just on the screen of the field jacket, you'll be able to see, in addition to the dinosaur's skull, there's this big, beautiful palm frond that was preserved with the dinosaur. So really remarkable that this was preserved, right before the single worst day of life on Earth, when all the dinosaurs went extinct 66 million years ago. So, and I think too, I guess if we can look again at the picture of the what the Hell Creek Formation looked like, which is the rock unit in which this dinosaur came from, gives you a better understanding of, we don't have things like palm trees up in North Dakota today. North Dakota looks a lot like this, where there are these big, beautiful badlands of these rolling hills of, mud, sand, kind of what we call gumbo hills, just these big layers of mudstone preserved out on the landscape. So not lots of big bushy trees with big leaves, big broad leaves, not lots of palm fronds, but instead lots and lots of rock. So very, very different environment today.
Very cool. When we're looking at this landscape, I do see a question in the chat, and it's, how often do you find dinosaur fossils? Is this one of those things like you walk through this badlands area and there are just fossils falling out of the hill, or you have to look a little harder than that?
That is an awesome question from the chat, and something that's amazing about going up to this area in the Hell Creek Formation in North Dakota and South Dakota and Montana is that it's one of the most fossil-rich places in the world. If you're walking around in the right rock units, it's not unusual to find several different dinosaur fossils all in one day. Not all of them are big, beautiful T-Rex fossils that are worth bringing back to the museum, but there are tons and tons of fossils out in this area. It's very, very rich.
Yeah, I'd love to also share with you guys. So of course, we have this beautiful T-Rex fossil that we've been so lucky to work on here at the museum. But in addition to T-Rex, the Hell Creek Formation and the same general area that Salvador just mentioned has produced scores and scores of really amazing fossils of not just T-Rex. So some of my favorite things that are on the table here are this that's right at the front. So these are a series of what we call caudal vertebrae, or those are tail vertebrae. And this is from a duck-billed dinosaur called Edmontosaurus. And what's really special about this fossil is that all of these vertebrae are preserved in the same way in which they would have been in the dinosaur's body when it was alive. So we call this articulation, which means that all of the bones are kind of in the exact same spot as when the dinosaur's tail would have been attached to its body in real life. So really common to find these types of things out on the landscape, in addition to some of the other critters that we have here on the table.
Another dinosaur that you might be familiar with that lived alongside T-Rex is this friend right here. And this is actually not from North Dakota, but it's something that you find in North Dakota a lot. This is you can probably guess, Triceratops horn. So Triceratops had a horn on its nose as well as two above its eyes. This is one of the big pointy ones from above its eye, just like that. And I'm a big fan of this one because this is a local fossil from right near the Denver area where we do a lot of our work.
Cool. And you may notice too that a lot of the fossils on this table may look a little bit crusty or broken or fragile. And so a lot of the work that Salvador and I do working in the fossil preparation lab is using different tools and things to help keep these fossils together. So in this container here is one of our most important tools. So this is an example of some of the glue that we use in our fossil lab. And I guess I'm wondering, and if it's okay with Kate, I'd like to ask, why do you think we need to use so much glue on dinosaur fossils? Or really any fossils, I would say.
Yeah, why do we use glue? That is a big battle. And the funny thing is, I know that's not the only battle you have. You have
That's
tons.
true. We have lots and lots of glue in this lab. So why do we need this? Why do we need to use
so much
this?
glue? We might not have glue guesses, but we
That's
do have a lot
okay.
of questions for you. Oh, someone says they're old and fragile.
That's right. So perfect. So as we've mentioned, these fossils are, 67 million years old. They're very old, very fragmented. And even looking across this table, a lot of these things are preserved really beautifully. But even if we look at, these tail vertebrae that we were looking at just a moment ago, you can see some of them have really beautiful surfaces on them, but they're super cracked. They've been broken up over time. So we use the glue to help keep everything together, which is really important for our work in this lab space.
Nice. All right, can I throw some more questions your
Please.
way? I'm gonna give you like two, and then we're gonna invite our on-camera school to join us. So here is one, and it is kind of interesting. This is the first we've had of this question today. What is the size of a dinosaur brain? That's from someone named Reese.
That is a fantastic question. And it's one that we sometimes answer using really sophisticated tools. Sometimes we'll scan dinosaur skulls to see what the space would have been that its brain would have filled inside of that skull. And dinosaurs are reptiles, and they have a reptile brain that's much simpler than a mammalian brain. So some dinosaur brains on ginormous dinosaurs are only as big as a walnut. But of course, dinosaurs came in all different shapes and sizes, so their brain sizes varied as well. But they never got really big. Like you could see in this guy, in our skulls, your brain fills up most of the top of your head, but the brain on this T-Rex would have fit right back in this little area with the rest of the skull kind of expanded up around it. So it would have fit way back right in this little pocket down in there.
So they had big skulls, tiny arms, tinier brains.
Absolutely.
Bummer. Okay, that is a great question and an awesome answer, though. The more you know, dinosaurs might have had those different sized brains. All right, at this point, let's go ahead and get our on-camera schools or our on-camera school, I should say, to join us. So if Emily Russell's crew wants to go ahead and unmute and bring yourself on camera, we cannot wait to hear your questions for our scientists. And while y'all are getting ready, one quick reminder I have for you is if you could come up close to the camera and nice and loud ask your questions, just so that we can hear it clearly over the broadcast. Let's see.
So I guess we are good. Okay.
Hi.
Hi. That's a great tie-dye t-shirt. All right, what questions do you have for our friends in the lab here?
Were T-Rex arms actually chicken wings? Like chicken wings almost?
That's a really good question. Or did you ask, are T-Rex arms similar to chicken wings?
Yeah.
Yeah, in some ways, yes. So if we take a look at this picture of the T-Rex's skeleton behind me, I think that a lot of folks know that T-Rex is kind of has a reputation for having kind of dainty, small arms. And so I think that's a great way to think of it, is that the powerhouse of this animal is absolutely in the big sharp teeth and the big giant skull, and also these big, long, powerful legs. And so these arms weren't doing too much, very similar to a chicken wing that you might eat for dinner. So if you've ever seen a chicken wing or eaten one, you know that there's not a lot of meat on it. It's not very, it's not doing much for the chicken, but a chicken thigh or a chicken leg might have a little more meat on it, a little more robust. And that's really where the power comes from for this animal. So good question.
Very cool. That was some great kind of comparative anatomy.
Yes.
You just did what a lot of paleontologists have to do based on
Exactly.
currently living animals. What's another question from the classroom?
Why are T-Rex's heads so big but their brains so small?
I love that question. Yeah, why?
That is another great question, and one that lots of scientists ask. Their great big head was full of different muscles that were really useful for eating other great big animals like Triceratops and duck-billed dinosaurs. So it was really useful for them to have a ginormous head because they could have a ginormous mouth with lots of muscles attached to it. But their lives were probably pretty simple, and a lot of the animals that they were competing with also had small brains. So there wasn't a lot of pressure for them to grow big brains to outsmart the animals that they were hunting and competing against.
Can I ask an extension question? So if
Yes.
the brain only fit in like one narrow part of the skull, what are all these other holes and things for on the skull of this T-Rex?
Yeah.
What went there?
That is a really great follow-up question. And one of the answers, and that's a question that scientists ask because dinosaurs are extinct, and we don't have all of the muscles and soft tissues that would have been attached to the skull. So we have to look at modern animals to try to understand what the animal would have looked like in life. And so we look at Komodo dragons and crocodiles, like we talked about in the question that we asked of you earlier. And we look at these animals to learn that there are jaw muscles that go up inside the skull and attach right on top here. Its eyes would have fit right here, and they would have faced forward. And then this big open space helps to lighten up the skull while it's still strong across the top so that it can whip that big head around and bite Triceratops and pick them up and fling them through the air, but still have a relatively lightweight skull. Fantastic questions.
Oh,
Wow, very cool. Okay, what's another classroom question for us?
how are birds related to dinosaurs?
How are birds related to dinosaurs?
Yeah, excellent. So it's awesome that we covered that a little bit with the poll question. And I think too, if I can refer back to our skeleton picture here, even looking at kind of the body plan and the shape of the T-Rex, it kind of reminds me of other big type of bird animals that we have walking around on Earth today. So if you guys have ever looked at an ostrich or an emu, these are birds that have really big, long legs, big feet, really tiny little arms or wings, and then a really big skull relative to their body size. And so you can kind of think of ostriches and emus as almost like walking dinosaurs or walking T-Rexes. Something else worth mentioning is that there's a really cool fossil called Archaeopteryx that has what we call a mosaic of traits, or a combination of traits between birds and dinosaurs. So one example is that Archaeopteryx looks like a bird in that it has a lot of feathers, and it looks like it has wings, but if you look inside of its mouth, it has teeth, just like a T-Rex dinosaur. So it's really interesting to be able to use this fossil to compare and contrast kind of the evolution or the changes that dinosaurs underwent to become birds. But I think overall, for me anyway, it's looking at their body shape and body plan that reminds me about birds the most.
Very cool. Yeah. Someone earlier made the joke that you will never look at a dino chicken nugget the same way ever again. I want to ask kind of a follow-up question in that if some of the dinosaurs went extinct, why did the dinosaurs that evolved to modern day birds, why did they survive?
That's the million-dollar question, and we're working to crack that code right now. So I know that one of the hypotheses that folks have is about, did having some type of adaptation for flight aid in the ability to survive a big mass extinction event? And so is that one of the reasons that birds were able to survive better than dinosaurs? We don't know. It could also have to do with body size. There weren't things like emus and ostriches walking around at the same time as big dinosaurs like this. You can think more of things that were kind of like songbird size. So does it have to do with body size and body mass? But I don't know that there's a definitive answer to that. So all the folks on this call, you guys could become paleontologists and help us better understand that question.
Very cool. What is another classroom question?
What is the oldest dinosaur that you guys found?
Ooh, oldest
Mm.
dinosaur. I think this could go two ways too. Like oldest as in respect to when we are alive today, as well as oldest in its lifetime.
Like a grandpa dinosaur.
Yeah, that is a really fantastic two-pronged question. The oldest dinosaurs that we find in terms of geologic time were around about 200 to 250 million years ago. They lived in the Triassic, and there are one example of one of these old dinosaurs is Coelophysis, which is a small coyote-sized dinosaur that ran around in packs and was a little meat eater. And then the other question, how old do dinosaurs get? Well, let's talk about T-Rex, which is one of the dinosaurs that question has been asked the most about. T-Rex probably got to its early 30s at its very oldest, and we've figured that out by counting the little rings in their bones when we've taken slices and looked at the growth rings. And we know that these 30-year-old T-Rex are really old dinosaurs because they show old age features on their skeletons, things like arthritis and healed wounds, and all sorts of other clues that give us answers about how these dinosaurs lived.
Interesting. Interesting to think about a dinosaur with arthritis. Ouch. What's another classroom question for us?
How big is the T-Rex? I thought it was as big as a football field.
Oh, okay. Someone was guessing it was maybe the size of a football field, but was obviously surprised. So how big is it again? The
Holy
size of
smokes.
this T-Rex?
I'm happy that it was not as big as a football field because that would be pretty scary. So this T-Rex, the teen Rex that we have at DMNS right now, we estimate was about 25 feet long. But T-Rex, a full-grown adult T-Rex would have been about 40 feet long. So to compare this to something, if you think about your school bus that's parked outside in the lot of your school, about the length of your school bus from the tip of the dinosaur's nose to the tip of its tail, which is still a pretty significant size animal. So, but a football field would be a little too scary for me.
No such thing. Dinosaurs are all awesome. So here's a question kind of in follow-up from the chat. How fast was T-Rex? Like how fast is this school bus sized dinosaur moving?
That's another great question, and one that lots of scientists have tried to answer. And we think that we know that it was a predator, and like lots of predators today, it was really helpful for it to be able to move really quickly. So there's a good chance that T-Rex could have run as quickly as 40 or 50 miles per hour in order to hunt down its quick prey.
So we are definitely not outrunning a T-Rex. Noted.
Not with those giant
Cool.
legs.
What is the largest dinosaur bone that you have found? Whether or not it's T-Rex, I suppose.
Yeah, so even though T-Rex is this crazy giant apex predator of its time, of the late Cretaceous, there were dinosaurs walking around that were even bigger than T-Rex. So long neck dinosaurs like Argentinosaurus, for example, which is from South America, from Argentina, as you may have guessed. This dinosaur, has a femur that would be longer than I am tall, and I am almost 6 feet tall. And we have some of these big thigh bones in our own collection that are about that length. So pretty remarkable to think about something, with one bone in their body, their thigh bone would have been bigger than I am, which is pretty crazy.
Wow. If you like sauropods, you should look up our past recording of Super Sauropods, Fantastic Fossils, or come back in February 2025, because we're going to be talking a lot more about some of these big dinosaurs that don't eat meat, but they are large. Let's get at least one last question from the classroom before we do some more chat questions.
Are the T-Rex's bones bigger than regular animals?
Are T-Rex's bones bigger than regular animals? Is that right?
Yeah.
Okay.
Are their bones bigger than regular animals?
If by regular animals, you mean the other big predators that exist, the big meat-eating animals that exist on Earth today, then the answer is yes. When you think of big meat-eating animals, I think the biggest one is a polar bear that's walking around on Earth today. There are bigger meat eaters in the ocean, of course, but for things that are walking around like T-Rex walked around, polar bears are as big as we get today. And the biggest polar bear is nowhere near as big as a school bus. It's the size of a car. So T-Rex, yes, got much larger than regular animals we see today.
That is a good question. And now I'm also thinking about bus-sized polar bears and it's dark. Let's go ahead. I did see a number of students in a line. I love that you're all ready. So let's just keep asking questions from the classroom. What other questions do you have for our scientists?
Let me ask one, sit down, just give the other people a chance.
How big is the foot of a T-Rex?
Ooh, how big is the foot of a T-Rex?
Oh, wow. That's a good question. What can I compare it to?
How about the span right here?
Yeah, I mean, I'm trying to think of something that they would have. Oh, okay. How about like the top of, I saw that you guys are sitting in desks. So I would say that a T-Rex foot is probably about the size of the top of your school desk when it's all kind of, I don't know, sitting on the ground when it's not in motion. And what's really cool is that with this specimen T-Rex, we actually recovered one of the feet of this dinosaur. And something else cool that we're able to look at as paleontologists is not just the bones in the foot, but a lot of times we find footprints that are left behind by these dinosaurs. So we call them trace fossils. And they look like, if you've ever seen bird tracks on the side of a river or a stream of things that have landed there and, you know, walked around, creeped around in the area, they leave a little three-toed print, kind of similar to what we would expect from a meat-eating dinosaur. So pretty big, pretty large.
Great question. Yeah, if you find any of these trace fossil prints, let us know. That's a great find. All right, let's get another question from the classroom.
How big was their head?
Ooh, how big was their head?
So T-Rex, when it hatched out of its egg, it was probably the size of a little itty bitty house cat. But then, so they had a head that was probably pretty small. But then as they grew, this is what we think is maybe a 17-year-old juvenile T-Rex right here. And they would have gotten bigger to this size. And then eventually they would have gotten almost twice as long as this. There are T-Rex skulls that are 4 feet long, just these giant bobblehead dinosaurs. They get really, really big heads, big enough to fit your whole body in their mouth.
There's an awesome picture of Alex that looks like she's about to be eaten by our T-Rex fossil. So you guys could really get a sense of the scale. And this is just a teenager dinosaur, which is kind of crazy to think about. So it would have had no problem chomping through Alex's head right there.
Yikes.
Yeah.
That is very cool. These were awesome questions. Okay, I'm going to throw some of the chat questions your way. And I am so sorry because I'm obviously not going to be able to get all of them, but did T-Rexes attack each other? Here's one.
Oh, that's a really good question. So in T-Rexes and really in all kind of meat-eating dinosaurs, there are some examples of them kind of biting each other or fighting with each other. So one of those dinosaurs is called Majungasaurus that we find on the continent or the country of Madagascar, the island of Madagascar. And some of these fossils from this meat-eating dinosaur have little puncture wounds and scrapes and things all over the front of their face and the front of their skull. So scientists have inferred that these guys were in fact fighting with one another and maybe even eating one another. So the answer is yes, we do have some evidence for that they could have been fighting or biting.
Very cool. Well, maybe, I don't know. That also sounds aggressive too. Did they hunt in packs?
That's another fantastic question. And we do have evidence of some meat-eating dinosaurs hunting in packs. For example, that super old dinosaur called Coelophysis that's about the size of a coyote we were talking about earlier. We find fossils of those where there are tons of them together, indicating that they were living together and probably hunting in packs. We don't see that with T-Rex yet, but keep looking for fossils and maybe we'll find that. We do see it with other tyrannosaur fossils where they live in groups, or at least died in groups and likely hunted in packs. So we've got to keep looking for fossils and maybe we'll find that pack of T-Rex soon.
Very cool. Salvador, you're going to be really happy. We got the question. What's up with the small arms? What are their small arms for?
Please.
I love the small arms. So when T-Rex was a juvenile, its arms are actually a little bit bigger relative to its body, and then they don't grow as fast as the rest of it. So in the adult, the arms have gotten smaller and smaller relative to the body. We call that, so there's a good chance the T-Rex basically wasn't using its arms for anything. We call that a vestigial structure when it's sort of an evolutionary leftover that's kind of withered away. And I'm not sure if you knew that whales evolved from animals that walked on land, and modern whales still have little hip bones hanging out, floating inside their bodies that are vestigial structures that don't really do anything. So T-Rex arms might be similar to that. But T-Rex catches a lot of flack for having really tiny arms, but actually, if you go down to South America and to Africa and to Madagascar, you can find other meat-eating dinosaurs that have even stubbier, tinier arms relative to its body. So it's really pretty reasonable to think of T-Rex as big chickens walking around, pecking at the ground, not using their arms for much at all.
Okay, now that we're thinking about chickens, someone has asked a question. What would they sound like? Probably not like chickens, right? But how do we know what they would have sounded like?
That is a good question. There's no way that we can know for certain, right? And scientists have hypotheses by observing animals that are their closest living relatives today. So things like birds and crocodiles, and kind of having a better understanding of the noises that they make when they're either hunting or resting or working in a pack or living together, being in a community together. So using the information from animals alive today helps inform what these animals may have sounded like in their distant past. But there's no way to know for certain. We have no T-Rex vocal cords preserved in the fossil record.
Very cool. Okay, here's another question that I feel like might not also have an answer, but are we able to tell the sex of a dinosaur if it's male or female? If so, how?
There are some clues and some new science that give us hints into looking at that, but for the most part, this is a very complete dinosaur find, and we still have less than half of the skeleton. With clues like that, it's really hard to tell whether or not you have a male or a female dinosaur. If you think of modern animals, somebody gave the example earlier, like a peacock. If you look at the modern animal, it's really easy to tell the difference between a male and a female because the male has big, showy, extravagant feathers, and the female is just doing its thing, living its life. It doesn't have all those extravagant feathers. But if you look at the skeletons of those two animals, it's not as easy to tell them apart. But the new science that I was about to talk about before I sidetracked myself is there's something called medullary bone, where female animals, when they're making eggs, will actually pull calcium from their limb bones and move it to form those eggs. So in some cases, it's been inferred that we have female dinosaurs because the limb is missing some of its calcium. One way to know for sure would be if you found a fossil that had eggs in its belly, you would know that that was a female. So keep looking, please find more fossils.
And more fossils.
I want to find that fossil.
That would be awesome.
Incredible.
I know. And we did get the question earlier about the DNA, like making new dinosaurs. So Jurassic Park is really a distant dream, if not just a fairy tale, right?
Unfortunately.
Ah, or maybe fortunately, 'cause
Yeah.
we all know how it ends.
That's right.
We don't get DNA preserved in dinosaur fossils. And we've talked about lots of different bones that we get preserved, but something that we haven't talked about is that it's not just bones that are always preserved. This is one of my favorite fossils we have on the table right now. Are there any guesses as to what part of the body we might be looking at here?
Oh yeah, what are we looking at? Let's see. Ooh, we have scales. What else are folks thinking? Skin. Okay, skin, scales, lots of skin.
Bingo, you guys have got it. This skin fossil from a duck-billed dinosaur was forged in the Hell Creek, and it tells us that we can know not only by looking at the skeleton that dinosaurs were reptiles, but that they were covered in scales, just like all the modern reptiles like lizards and snakes you're familiar with today.
Cool. Well, in the interest of time, unfortunately, we're pretty much out. Is there any like closing words, or are there any closing words you want to leave our students with today? Becoming paleontologists, finding dinosaurs.
Yeah, so
Something
I
random?
think, to bring this all back to this Teen Rex and the discovery of Teen Rex, this fossil was found not by any folks that work here at the museum, not any folks that have, professional degrees or any type of special training. They were found by 3 kids that were just outside walking around, looking near their home in their backyard. So I would say, if you're interested in paleontology or becoming a scientist, just stay curious about what's in your backyard, about the natural world, and just go outside and keep exploring.
Absolutely. Paleontology is all about learning and continuing lifelong learning. We find out new things every day and are discovering new things all the time. So stay thirsty for knowledge. You had so many fantastic questions.
You really did. And I mean, I could see the chat, and there were still so many questions that we did not answer simply because of timing. So if you have questions, go research. And if you can't find an answer, become a paleontologist. And when you find that dinosaur, please let us know, because we want to come see it with you. And it might just be featured in a museum someday. A couple people we want to thank today. We have Kim and Riley, who you can't see because they're behind the camera and off scenes, making sure that today's tech happens. Of course, thank you, Natalie, and thank you, Salvador. Your knowledge and sharing all these amazing specimens was super cool. And thank you for your questions, whether or not they were from a classroom, on camera, or on the chat. We couldn't do without you. If you enjoyed today's program, I hope you'll come back next month. We have not one, but 2 scientists in action coming up. The first is not listed, and I'll mention that in a second. But on October 24th, we will be going behind the scenes elsewhere in the museum to shadow someone who works with zoology and brilliant bats and what they do. The other one that is not on here, but we're still doing and very excited about, is on October 8th. We have a special edition, Scientists in Action, that will be featuring actually 4 Indigenous female authors. And we'll be talking a lot about the intersection of art and science and writing and that Indigenous perspective. And it will be such a treat. So please look us up online. Teachers, register your classes, come back for another field trip behind the scenes, and we can't wait to see you next time. So see ya.